AS120. In this video, we are going to learn about covalent bond in consumer product. But before we start, let me introduce to you guys my teammates. First one is Syaza Yasmin and the second one is Yuni Illyaty. Before we go through about this topic, let me explain to you guys what is covalent bond. Covalent bond are formed when non-metal atoms share their electron to achieve stable neutral or attack electron arrangement. So there are three types of covalent bond, which is single bond, double bond, and triple bond. Let me explain to you guys one by one. So the first one is single bond. In chemistry, a single bond is a chemical bond between two atoms involving two valence electrons. A single bond is formed when one pair of electrons are shared between two atoms. For the example, chlorine. Chlorine has 7 valence electrons. To complete its octet, each chlorine shares its 1 electron, and a chlorine molecule Cl2 having a covalent bond is formed. The second one is double bond. A double covalent bond is where two pairs of electrons are shared between the atoms rather than just one pair. Some simple molecule containing double bonds, which is oxygen. Two oxygen atoms can both achieve stable structure by sharing two pairs. The double bond is shown conventionally by two lines joining the atoms. Each line represents one pair of shared electrons. The third one is triple bond. For example, nitrogen. Nitrogen has a triple bond between two nitrogen atoms. According to the octet rule, nitrogen atoms need to bond 3 times. The nitrogen molecule is diatomic, meaning that two atoms of the same element are connected in a pair. For your information, covalent bonds are divided into two, which is polar covalent bond and non-polar covalent bond. Polar covalent bond happens when electrons are shared unequally. Non-polar covalent bond happens when electrons are shared equally. The example for polar covalent bond, which is water. Water is polar molecule and also acts as a polar solvent. When a chemical species is said to be polar, this means that the positive and negative electrical charge are unevenly distributed. The positive charge comes from the atomic nucleus, while the electrons supply the negative charge. It's the movement of electrons. The example of non-polar covalent bond, which is chlorine. Chlorine molecule displays a non-polar covalent bonding. Chlorine belongs to group 17 of the modern periodic table and thus has 7 electrons in the valence shell. The two chlorine atoms share 1 electron pair between each other to get a stable octet. Since the two atoms are the same, the covalent bond is non-polar. There are so many consumer products that have covalent bond. The first one is vinegar. Vinegar is organic compound with a formula. Vinegar is a solution of acetic acid in water and contains between 5% to 20% ethanol acid by volume. Acetic acid is also known as ethanol acid, acetic acid, and methane carboxylic acid. So now we can see that there are chemical equations of acetic acid. The first one is methanol add with carbon monoxide and produce acetic acid. The second one is from ethanol to be acetaldehyde and be acetic acid. So, is acetic acid is a vinegar? As we know from my explanation before, vinegar is a solution of acetic acid in water and contains between 5% to 8% ethanol acid by volume. Ethanol acid is a very important organic compound in the day-to-day living.
Next, let's move to sugar, or we know as sucrose. Sucrose, a disaccharide, is a sugar that composed of glucose and fructose subunits. It is produced naturally in plants and is the main constituent of white sugar. So, this is the structure of sucrose that made from glucose and fructose. From the structure, molecule has been composed of oxygen and form this family. So, this is the electron arrangement of sugar. From the structure, we can see that there are covalent bond between atom oxygen. Next, these are sugar crystals, orderly arrangement of sucrose molecule. There are three functions of sucrose, which is first, sucrose can undergo a combustion reaction to yield carbon dioxide and water. Second, sucrose can be dehydrated with the help of H2SO4, which acts catalyst to give rise to black solid, which is rich in carbon. Third, upon hydrolysis, the glycosidic bond linking the two carbohydrates in a C2H22O11 molecule is broken, yielding glucose and fructose. Next is cooking gas or propane. Propane is non-renewable source of energy. It is obtained from crude oil and natural gas. LPG is composed hydrocarbons containing 3 or 4 carbon atoms. The normal component of LPG gas are protein C3H8 and butane C4H10. Small concentration of other hydrocarbon may also be present. So, the picture shown is referred to the structure of propane. From the structure, we can see that 3 molecule carbon with chemical formula of LPG gas, propane as C3H8. Next is nail polish, film-forming polymers. Conventional nail polish contains a polymer dissolved in a solvent. The most common polymer is nitrocellulose. Gel nail polish is made up of methacrylates, monomers, and a photoindicator such as benzoyl peroxide. It exposes the mixture to uplight, triggers polymerization and solidification.
Next, we move on to plastic. The polymer used in plastic manufacturing is a chemical compound that contains carbon and hydrogen linked together via covalent bonding. There are two types of polymers, that is natural polymers and synthetic polymers. Natural polymers are naturally available and can be obtained from our surrounding, and the example is starch, protein, and cotton. For synthetic polymers are man-made through chemical reaction in laboratories and factories. The example is nylon, polyethylene, polystyrene, and polyvinyl chloride (PVC). Next is the structure of plastic for monomer and polymer. First is ethene for monomer, and for polymer is polyethylene. The characteristic is durable and strong. The users are usually plastic bags, plastic bottles, and plastic packaging. Second is propene for monomer, and for polymer is polypropene. For polypropene and propene, it is very durable. It is usually used for toys and textile. Next is chloroethylene, or we call vinyl chloride. The polymer is polychloroethylene or polyvinyl chloride (PVC). Polychloroethylene is very strong and hard. It is commonly used for water pipes and electrical insulators. Last would be styrene, and the polymer is polystyrene. Polystyrene is light and heat insulator. It is commonly used for heat insulator and food packaging. We are moving on how monomers turn to polymers. Monomers turn to polymers by condensation polymerization. Condensation polymerization involves at least two different monomers.
The monomers involved consist of two functional groups that will take part in the polymerization reaction. As we can see from figure 4.3, condensation polymerization reaction to produce terephthalate. Ethanediol and terephthalic acid produce two terephthalate and water. For figure 4.4, condensation polymerization reaction to produce nylon. Ethanediamine and decanediolite dichloride produce nylon and hydrochloric acid. Last but not least, we move on to types of polymers. There are three types of polymers, that is thermoplastic polymers, thermosetting polymers, and elastomer polymers. For thermoplastic polymers is a polymer that can be repeated remolded upon heating and can be recycled. When heated, the thermoplastic polymer melt and solidify when they are cooled. For example of thermoplastic polymers is polyethylene, polyvinyl chloride, PVC, and nylon. Next is thermosetting polymers. Thermosetting polymers cannot be remolded after heating. Thermosetting polymers normally disintegrate or burn upon heating and cannot be recycled. The example of thermosetting polymers is melamine and bakelite. Last is elastomer polymers. Elastomer polymers can be scratched and returned to the original shape when released. It also possesses high elasticity properties. For example of elastomer polymers is polyurethane and citrin butadiene rubber SBR. I think that is all from us. Thank you for your time.